Our planet Earth, the only home we have. With billions of inhabitants, ceaseless industrial activity, and natural phenomena that move enormous amounts of matter, you might think the Earth would be drowning in its own waste. However, our blue planet has such a sophisticated and efficient self-cleaning ability that it often goes unnoticed. From the deepest ocean abysses to the top of the atmosphere, Earth operates a cleaning machine on a monumental scale. It's an intricate and beautifully orchestrated system where every component, from the most majestic tree to the tiniest bacterium, plays a crucial role. This isn't a passive process, but a symphony of biogeochemical cycles, biological interactions, and physical phenomena that work together to purify the air, clean the water, and recycle nutrients. In this video, we'll explore how the oceans, the blue lungs of our world, process and purify their vast waters. We'll delve into the silent yet powerful work of forests, which act as giant filters for our air and guardians of soil health. We'll discover the hidden kingdom of fungi, the masters of recycling, and how a simple rainfall becomes a purifying shower for the atmosphere. We'll witness the tireless work of microorganisms that clean our waters, and of scavenging animals that, far from being agents of death, are essential for the health of ecosystems. Join us to unveil Earth's amazing self-cleaning machinery, a planet that, despite our challenges, constantly fights to stay clean and vibrant. The oceans, which cover more than 70% of our planet's surface, are much more than just vast expanses of saltwater. They're the heart of Earth's climate system and are home to incredible biodiversity. But how do these aquatic giants, which receive an enormous amount of sediment, natural waste, and, unfortunately, human pollution, manage to stay clean? The answer lies in a combination of physical, chemical, and biological processes. One of the main ways the oceans clean themselves is through thermohaline circulation, often called the Great Ocean Conveyor Belt. This is a global circulation pattern driven by differences in water temperature, thermo, and salinity, haline. In polar regions, cold, salty water becomes denser and sinks, beginning a slow, deep journey through the world's ocean basins. As this deep water travels, it carries oxygen to the depths, which is essential for life and for the decomposition of organic matter that sinks from the surface. Eventually, this deep water resurfaces in other parts of the world, bringing nutrients to the surface and completing a cycle that can take hundreds of years. This constant process of mixing and circulation helps to distribute and dilute pollutants, preventing them from accumulating in lethal concentrations in a single place. It's a planet-wide washing system, slow, but incredibly effective. Sunlight bathing the ocean's surface plays a crucial role in water purification. The sun's ultraviolet, UV, radiation has a disinfecting effect, capable of eliminating harmful bacteria and viruses in the upper layers of the ocean. Additionally, sunlight drives photosynthesis in phytoplankton, the microscopic marine plants that form the base of the ocean's food chain. Not only does phytoplankton produce a large amount of the oxygen we breathe, but it's also a key player in keeping the ocean clean. Through photosynthesis, they absorb dissolved carbon dioxide from the water, which helps to mitigate ocean acidification. When these tiny creatures die, they clump together and slowly sink to the ocean floor, a phenomenon known as marine snow. This marine snow carries organic matter, carbon, and in some cases, attached pollutants with it. Upon reaching the seabed, this material is either consumed by decomposer organisms or buried in the sediments, effectively sequestering carbon and pollutants away from the active biosphere for long periods of time. In areas where the land meets the sea, ecosystems such as mangrove forests, salt marshes, and seagrass beds act as incredibly efficient biological filters. Often called the kidneys of the planet, these coastal wetlands trap sediments and excess nutrients like nitrogen and phosphorus from agricultural runoff, as well as other pollutants, before they can reach the open ocean. The roots of plants in these ecosystems slow the flow of water, allowing suspended particles to settle. Microorganisms living in the soil break down organic matter and transform chemical pollutants into less harmful forms. Therefore, protecting and restoring these coastal ecosystems is vital for maintaining the health of our oceans. The immense size of the ocean gives it a massive dilution capacity. While it's not a long-term solution for pollution, the ability to disperse substances across vast volumes of water can reduce their immediate impact on localized areas. However, it's crucial to understand that the ocean's self-cleaning capacity is not infinite. The rate at which we introduce pollutants, especially plastics and persistent chemicals, is outpacing the ocean's ability to process them. The ocean is showing signs of stress, such as acidification, dead zones from a lack of oxygen, and the accumulation of garbage in ocean gyres. Supporting the health of the ocean means reducing our pollution burden and protecting the natural systems that so diligently work to keep it clean. If the oceans are the planet's blue lungs, forests are undoubtedly its green lungs. Majestic and serene, trees are much more than simple elements of the landscape. They're living factories of pure air, natural filters for pollutants, and anchors that protect the vitality of the soil. Their work of cleaning is constant, silent, and absolutely essential for life on Earth. The most well-known and perhaps the most vital process performed by trees is photosynthesis. Using the energy from sunlight, trees absorb carbon dioxide from the atmosphere, one of the main greenhouse gases responsible for climate change. Through a series of complex chemical reactions, they convert carbon dioxide and water into glucose, which is their food, and release oxygen as a byproduct. Each leaf on a tree is a small photosynthesis factory. A single mature tree can absorb up to 48.5 pounds of carbon dioxide a year and release enough oxygen to sustain 2 people for that same amount of time. On a global scale, the world's forests are massive carbon sinks, playing an irreplaceable role in regulating the Earth's climate. But the air purification trees provide goes beyond carbon dioxide. Their leaves, branches, and bark act as a giant filter, trapping a wide variety of air pollutants. Fine particles like dust, soot, and pollen, which can be harmful to human respiratory health, stick to the surface of leaves and bark. Rainfall then washes these particles to the ground, effectively removing them from the air we breathe. In addition to particles, trees can also absorb gaseous pollutants like sulfur dioxide, nitrogen oxides, and carbon monoxide, which are byproducts of burning fossil fuels. Stomata, the tiny pores on leaves through which trees breathe, can absorb these gases and metabolize them into less harmful compounds. Studies have shown that trees in urban areas can significantly reduce the concentration of air pollutants, improving the quality of life for city dwellers. The cleanup work of trees isn't limited to the atmosphere. It extends deep into the soil. Through a process called phytoremediation, trees and other plants can clean up contaminated soil and groundwater. Their roots act as a natural filtration system, absorbing water and nutrients from the soil. In this process, they can also absorb a variety of pollutants, including heavy metals, such as lead, cadmium, and mercury, pesticides, and solvents. Once inside the tree, pollutants can either be stored in the roots, stems, or leaves, a process known as phytoaccumulation, or they can be transformed into less toxic substances through the tree's metabolism, which is called phytotransformation. Some plants can even release enzymes through their roots that break down pollutants in the surrounding soil. Phytoremediation is a green, low-cost, and aesthetically pleasing cleanup technology that is increasingly being used to restore contaminated sites. The extensive root systems of trees act as an anchor for the soil, holding it in place and preventing erosion caused by wind and water. Soil erosion is a serious problem that can lead to desertification, the loss of fertile farmland, and the sedimentation of waterways. When it rains, the tree canopy intercepts a significant amount of water, reducing the force with which the rain hits the ground. The water that reaches the ground is absorbed by the layer of leaf litter and the roots, which recharges underground aquifers instead of running off the surface and carrying away valuable topsoil. By protecting the soil, trees secure the foundation for healthy ecosystems and productive agriculture. Trees are true ecosystem engineers. Their presence creates a cleaner, healthier, and more stable environment. Planting a tree is one of the most direct and effective actions we can take to help the planet in its monumental task of self-cleaning. Under our feet, in the darkness of the forest floor and in decaying matter, exists an often overlooked kingdom of organisms of monumental ecological importance: fungi. Far from being mere curiosities that sprout after the rain, fungi are nature's primary recyclers, the masters of decomposition who ensure that life can continue from death. Without them, the planet would literally be buried under a mountain of dead organic matter. Fungi's most critical cleanup function is decomposition. They are one of the few organisms on Earth capable of breaking down lignin and cellulose, the tough and complex structural components of wood and plant matter. Through the secretion of powerful extracellular enzymes, fungi break down dead organic matter, whether it's fallen trees, dry leaves, or dead animals. This decomposition process is not just a cleanup in the sense of removing waste, it is a fundamental act of recycling. By decomposing organic matter, fungi release the essential nutrients that were trapped within it, such as carbon, nitrogen, phosphorus, and other minerals. These nutrients are returned to the soil in a form that can be absorbed by living plants, thus closing the nutrient cycle and allowing the ecosystem to sustain itself. Without fungi, these nutrients would remain locked away, and forests and other ecosystems would wither away from a lack of nutrients. One of the most fascinating and beneficial associations in the natural world is the symbiosis between fungi and plant roots, known as mycorrhiza. More than 90% of the plants on Earth form this relationship. The fungus forms a vast network of microscopic filaments called hyphae, which extend far beyond the reach of the plant's roots. This mycorrhizal network not only nourishes plants, but also contributes to soil cleanup. Hyphae can help to stabilize the soil, preventing erosion. The remarkable ability of fungi to break down complex compounds has led to the development of an innovative technology called mycoremediation. This is the use of fungi to degrade or absorb environmental pollutants. Some species of fungi can decompose a surprising variety of pollutants, including hydrocarbons, such as oil and diesel, pesticides, and even synthetic materials like plastics. The same enzymes they use to break down lignin can break the chemical bonds of these pollutants, transforming them into less toxic or harmless substances. Mycoremediation is a promising field of research that harnesses the power of the natural biochemistry of fungi to solve some of our most difficult pollution problems. While we often think of parasitic fungi as a negative thing, from an ecosystem perspective, they also play a cleanup role. By attacking old, weak, or sick trees, parasitic fungi help accelerate their death and decomposition, opening up space and releasing resources for new, healthier plants to grow. They act as a natural quality control system, ensuring the forest remains vibrant and resilient. The fungal kingdom is a testament to the complexity and interconnectedness of life on Earth. Through their tireless and often invisible work, fungi ensure that the cycle of life, death, and rebirth continues, keeping ecosystems clean, healthy, and productive. In the great web of life, death is an inevitable part of the cycle. But what happens to the bodies of animals that die? If they weren't removed efficiently, landscapes would be filled with decomposing carcasses, becoming focal points for disease. This is where an often maligned but ecologically vital group of animals comes into play: scavengers. Led by vultures, this sanitation crew of nature provides a fast, efficient, and crucial cleanup service for the health of ecosystems. Vultures are the quintessential scavengers. They've evolved to be incredibly efficient at locating and consuming carcasses. With their keen eyesight, they can detect a dead animal from great heights. Often, the descent of a single vulture alerts others for miles around, and in a short time, a flock of vultures can congregate to clean up a carcass. Their biology is perfectly adapted for their diet. They have featherless heads and necks, which helps them stay clean while feeding inside a carcass. But their most remarkable adaptation is their digestive system. A vulture's stomach acid is exceptionally corrosive, with a pH close to 1, virtually the same as car battery acid. This extremely acidic environment allows them to digest decaying meat and, more importantly, to destroy dangerous pathogens that could be lethal to other animals. By consuming a carcass, vultures eliminate bacteria that cause diseases such as botulism, cholera, and anthrax. They act as a dead end for diseases, preventing them from spreading throughout the ecosystem and reaching livestock or humans. They are, literally, the immune system of the landscape. Although vultures are the most iconic, they aren't alone in this work. A wide variety of animals participate in the cleanup process. For example, mammals like hyenas, jackals, coyotes, and foxes are efficient scavengers that use their keen sense of smell to locate carcasses. Their powerful jaws can crush bones, ensuring that every part of the dead animal is utilized. In addition to vultures, crows, some eagles, and hawks also feed on carrion. And we can't forget the Andean condor, which helps keep high mountain ecosystems healthy. Once the larger scavengers have finished, insects take over. Burying beetles, carrion flies, and their larvae consume the remaining soft tissue, while other beetles specialize in skin and hair. And in aquatic ecosystems, crustaceans like crabs and lobsters, as well as various fish, act as scavengers, cleaning dead organisms from the bottom of rivers, lakes, and oceans. The speed at which scavengers remove a carcass is crucial. A dead animal can contaminate nearby water sources and become a breeding ground for flies that can transmit diseases. Scavengers remind us that in nature, nothing goes to waste. They transform death into life, recycling nutrients and keeping ecosystems clean and safe. They are an essential part of Earth's self-cleaning machinery. Throughout this journey, we have witnessed the astonishing and complex self-cleaning machinery of our planet. We have seen how the great oceanic conveyor belt purifies the deep sea, how trees act as giant filters for our air and soil, and how the hidden kingdom of fungi recycles the very essence of life. We have learned that every raindrop is a shower for the atmosphere, that legions of bacteria work tirelessly to purify our waters, and that scavengers are the sanitary guardians of ecosystems. This isn't a collection of isolated processes, but an intricately woven symphony. The rain that cleans the air delivers water to trees, whose roots, in symbiosis with fungi, filter that water while anchoring the soil. The nutrients released by fungi feed the phytoplankton in the ocean, which in turn cleans the atmosphere and water. It's a system of checks and balances, of cycles and feedback loops, that has been perfected over eons. Understanding these mechanisms fills us with awe at the Earth's resilience and inherent wisdom. However, it should also serve as a call for humility and action. Our planet's self-cleaning capacity, while powerful, is not infinite. On many fronts, our activities are overwhelming these natural systems. Plastic pollution is suffocating our oceans at a faster rate than they can process it. Greenhouse gas emissions exceed the capacity of forests and oceans to absorb them. Synthetic chemicals that we introduce into the environment often don't have a natural counterpart, and therefore, no bacteria or fungi have evolved to break them down. The challenge of our era is to learn to live in partnership with Earth's cleaning systems, rather than working against them. This means reducing our waste production at the source and transitioning to a circular economy where materials are reused instead of being discarded. Protecting and restoring vital ecosystems like forests, wetlands, and coral reefs, and developing technologies that mimic and support nature's cleaning processes. The Earth is our only home, a living and self-regulating system of breathtaking beauty and complexity. By understanding and appreciating its remarkable ability to clean and renew itself, we can make more informed and conscious decisions to ensure that this incredible planetary machinery can continue to function for generations to come. The cleaning of the planet isn't just the Earth's concern, it's also our shared responsibility.